very often be interested in factoring quadratic trinomials. What does that mean? Remember, quadratic means degree 2. Trinomial means 3 terms. So we're talking about polynomials that look like x squared plus 5x minus 6. And we would like to write this as a product of 2 binomials. We know what the 2 binomials are going to look like, right? They're going to be 2 linear binomials. That's always going to happen. A quadratic trinomial will always be the product of 2 linear binomials, if we can factor it at all. So we'll have an x and an x here, both coefficient 1 because we want their product to be x squared. And here we'll have 2 constants whose product has to be -6. Along this diagonal, we'll find our x terms, and they will add up to +5. But wait, this coefficient will be just this number. This coefficient will be just this number. So what we really want here is 2 terms where the sum of the coefficients is 5 and the product of the coefficients is -6. Well, we can write down all of the numbers whose product is -6, that is, all of the pairs of factors of -6. Right? We've got -6 times 1, -3 times 2, -2 times 3, -1 times 6. What do we get when we add up these factors? -6 plus 1 is -5. -3 plus 2 is -1. -2 plus 3 is +1. -1 plus 6 is +5. -1 plus 6 is our winner, I think. So we'll have, it doesn't matter which order I write them in, -1x, +6x. And then, what will my greatest common factors be? In this row, I think my greatest common factor will be just -1. Right? X times x is x squared. -1 times x is -1x. Pretty good. X times what is 6x? Well, x times 6 is 6x. Is it true that 6 times -1 is -6? Why, yes it is. What are our factors then? X minus 1 times x plus 6. Again, what was the key move? We knew that the x squared term had to be up here. We knew that the constant had to be down here. Our key move was splitting up the middle term. Let's see that again. Let's say we want to write this polynomial as a product of 2 binomials. Well, here we'll have x squared, and here we'll have +12. We want to split up the x term so that the sum of the coefficients is 7, and the product is 12. How do we get 12 as our product? Well, 1 times 12, 2 times 6, 3 times 4, and then the other way around, right? So 1 plus 12 is 13, 2 plus 6 is 8, 3 plus 4 is 7. There we go then. So we'll have 3x and 4x. What common factors do we see in this row? Well, an x. And in this row, a 4. What's left in this column? X times what gives me x squared? X times x gives me x squared. Does x times 4 give me 4x? Why, yes, it does. X times what gives me 3x? X times 3 gives me 3x. Does 3 times 4 give me 12? Why, yes, it does. What are my factors? X plus 4 times x plus 3. All right, I'm going to give you one of these to try. Write x squared minus 9x plus 18 as a product of two binomials. Pause the video and try this now. All right, so we're going to have our x squared here and our positive 18 down here. Now we want to find two numbers whose product is positive 18 and whose sum is negative 9. I think those are going to have to both be negative numbers. All right, so we'll have negative 1 times negative 18, negative 2 times negative 9, negative 3 times negative 6, and then the other way around, right? Those are the only ways to factor 18. Negative 1 plus negative 18 is negative 19. Negative 2 plus negative 9 is negative 11. Negative 3 plus negative 6, there's our negative 9. So here we have negative 3x. Here we have negative 6x. What are the common factors in my rows? Here I have an x, and here I have a 3. X times what gives me x squared? X times x gives me x squared. Does x times 3 give me negative 3x? Well, no, it gives me a positive 3x. Maybe this better be a negative 3. Yeah, x times negative 3 gives me negative 3x. X times what gives me negative 6x? X times negative 6 gives me negative 6x. Does negative 6 times negative 3 give me positive 18? Yes, it does. So what are my factors? X minus 3 times x minus 6. Notice what we saw with the signs. When the constant was negative and the middle term is anything, when we split up the middle term, we have one positive and one negative, because that's what we need for the product to be negative. When the constant was positive and the middle term was positive, when we split up the middle term, they were both positive. When the constant was positive and the middle term was negative, then we split up the middle term as both negative.